Hello and welcome to my presentation on macOS. My name is Rajan Velez and this is for Professor Monahan's Operating Systems class. Today we'll be covering the processes, process states, the activity monitor, scheduling policies and practices, memory management, file management, graphics, networking, and network testing. macOS's approach to processing is a layered approach. So from the bottom, we have the kernel, which basically controls all of the main processes of the system. You have the core services, above you have the application services, and then you have the application environment, which is where the user interacts with the system. And from there, when the user, for example, issues a command or clicks a button, it'll be processed by the application services, and anything further from there will go down to the core services. When a process goes through macOS, it can fall under five categories. It will always start in the idle process or SIDL, and the state is when the process is initially or partially created. When the process is ready to be run, it goes into SRun. Sleep is when the process is waiting to be triggered, and stop is when the process has been stopped. And when the process has been partially terminated but not completely, it will go into SZOMB, which is short for zombie. macOS has a great way to monitor the processes, and you can find this in the activity monitor. The activity monitor will first categorize everything into five categories, and this will be CPU, memory, energy, disk, and network. If you look under the CPU tab, things will be further categorized in the process name, the percentage of the CPU used, the CPU time, threads, idle wake ups, the percentage of the GPU that's used, the GPU time, the PID, and the user that is where the processes are taking place. Furthermore, it'll also report to you the percentage of the system used. In my case, at the time that this presentation was being created, 7.04% of the system was being used. Under the user specifically, it will show how much of the CPU is being used by the user. So in my case, it was 9.34%. In the idle state, which is how much of the CPU was idle at the time, it'll show that here I have 83.62% idle. CPU load was blank, but uh, next to that, you can see that at the time that the presentation was being created, I was using 2,108 threads, and there were 460 processes across those 2,108 threads. Next, we have the scheduling policies and practices of macOS, and we can see here that the schedule that is used is an advanced version of the CMU Mach 3 scheduler. All of the threads are prioritized as normal, system high priority, kernel mode only, and real-time threads. The real-time threads are given the highest priority, but at any time, depending on what processes are occurring, the priority of the threads may change. macOS takes a rather unique approach to its memory management usage, and this is by using a virtual memory system. The memory is managed by the virtual memory system to reduce any unnecessary RAM usage. Anything that's not currently in use is stored on the hard disk. The writable data is not removed from the memory. Instead, the system will reduce the amount of free memory and account for the writable data that way. Any applications that can't free up memory are automatically removed. If there aren't any pages available, the system, macOS, will use the repository to make additional space. Any kernel information and data structures are stored in the wired memory. Applications and other software cannot use any of the allocated memory. If in any instance that the amount of available pages falls below a certain threshold, which was not specified, the system will make new ones available by freeing up inactive pages. For its file management system, macOS uses flash storage. The disk space is partitioned in a container, and this is only on demand. Fortunately, any files that need to be encrypted can be encrypted for security purposes. And the best thing about the file management system of macOS is that it has case sensitivity. So, in the instance that you, for example, want to name two files case, you can put one in all caps and one lowercase, and they will be created as separate files. In the event that you have two files named case and they're both caps, it'll instead put one as case and the other will be case with the one in parentheses. And if you have another, for example, a third file, it'll be case with the two in parentheses and so on. macOS is well known for its graphics, and many content creators use it to create uh, pictures, logos, animations, movies. Many YouTube content creators use macOS for its smoothness, and also it can be found owned by many gamers, which use it for its graphics as well. And macOS is powerful with its graphics because it uses a range of seven different types of processors or GPUs. And the types that are used are Intel UHD graphics, Iris Plus, Iris Pro graphics, Iris graphics, HD graphics, and NVIDIA GeForce. Many Macs have two graphic processors, and the processors that are used are classified as a discrete GPU or an integrated GPU. The discrete GPU gives a lot more powerful graphics compared to its counterpart, the integrated GPU. However, the discrete GPU uses a lot more power, and in the case of a MacBook, it will use up a lot more battery. The integrated GPU saves battery, but it doesn't provide as much graphic power as its discrete GPU counterpart. In the event that you're using a Mac and you want to know what type of GPU is being used by your system, you can simply find this in the About This Mac section. You can locate that by going to the top left hand corner to the Apple logo, and in the drop down, the first section will be About This Mac. When you click on About This Mac, it'll show you a list of information about the Mac that's currently used. And in my case, when you go to the graphics area, you'll see that my Mac is using an Intel Iris Plus graphics GPU. macOS shows its versatility by using external GPUs. An external GPU is used to enhance the graphics. And the requirement is that you need to have macOS High Sierra 10.13.4. And the great thing about the eGPU is that it'll give more power to the GPU that's in use. This is very useful for people that are doing heavy gaming and also people that are doing a lot of processing, for example, on a virtual reality headset. One network capability of macOS is that it'll allow you to see other hosts that are on the network. And this can all be found in the Finder application. And macOS does support other operating systems that are on the network. So if there's another computer that's using Windows, you can simply click on the system and you'll be able to see its directory. Mac also supports the viewing of other Apple devices such as airports, time capsules, and FTP servers, and this is all listed in the locations dropdown in the Finder application. Connecting to other devices on the macOS system is very simple. You will simply go to the Finder application, which looks like this guy here with the smiley face. You will go to the locations drop down, and when you click on the arrow, it'll drop down anything that's on the network. In my case, there aren't any other computers or hosts on the network, but it does accept cloud services such as OneDrive and Google. Another great aspect of Mac's networking capabilities is that it'll allow you to conduct network testing, and this is done in the terminal application where commands can be entered. The command to initiate a network test is network quality. The words must be together with a capital Q. And the information that it provides is the upload capacity, download capacity, upload flows, download flows, and the responsiveness of the network. The upload capacity and download capacity by default are run together, but they can also be run separately. And down here you can see that this is the graphic for the terminal application. This is what it'll look like when you're looking for it in the system. And this is a window of a blank terminal with no commands entered. Here we have an example of a network test that I conducted using the network quality command. Now I went to the terminal application as discussed in the previous slide, and next to it here in this graphic, we have a picture of my own network test. The upload capacity at the time of the test was 71.489 megabits per second. The download capacity was 86.135 Mbps. The upload flows was 20. The download flows was 20. And the responsiveness of my network was medium at 528 RPM. macOS is a very strong and versatile system, and it offers many features to its users, whether you want to do document processing or creating content. Many of the processing states that are available are almost traditional, ranging from idle to stop, with the exception to its zombie state. The activity monitor offers a great view of the processes that are occurring and how much power they're using. The memory management system is dynamic because of its virtual memory system, which maximizes RAM. The file management system creates great options to store different variations of files. macOS's graphics are very strong and offer enhancements with support such as from eGPUs or enhanced graphics processor units. Its networking capabilities allows the system to connect to other devices that are running on the network, whether they're on macOS, other Apple operating systems, or if they're on foreign operating systems such as Windows. The network testing is very simple and it offers great information on network statistics. Thank you so much for your time today.